Hey everybody, this is Matt with mathsmath.com. Thanks for joining us here today as we talk about finding unknown measures in similar figures. So we're going to be looking at similar shapes and we're going to be talking about how to use proportions to solve for those missing lengths or measures or lengths or measures. Alright, let's do it. Alright, so we're in the Common Core Math Standard of Geometry and we're going to be creating and describing shapes today, especially in real-world problems as we look at the solar system. Today's a pretty cool day as we talk about space. Alright, so this is our guiding question. How can you find unknown lengths of similar shapes using proportions and ratios? So we're going to be doing that. We're going to be looking at scale models of the solar system. We're going to be looking at shapes and comparing their ratios with proportions and finding those missing lengths. Let's do it. Alright, so here is the Earth. You like that drawing I made? There it is. There's Africa, South America, and these sweet cloud systems. Alright, so what we're going to do is we're going to talk about how if I draw this bowling ball, wait, no, that's the moon. If I draw the moon here and the Earth here, and I make these scale figures, what is the actual distance from the Earth to the moon? If I want to set it up and make it pretty accurate, and these are at a scale size, how far would I need to separate them if I was going to actually make it accurate? Or if I could zoom in, make it bigger to life size, it would be correct. Alright, so let's do that. What we're going to do is we're going to talk about these similar shapes. So just like a scale model of the Earth and the bowling ball, you make it bigger and you make it smaller. And what are those missing lengths that you might have if you have a scale or something like that? So this is going to be key in setting up proportions. Corresponding lengths are proportional. Remember that? Corresponding lengths are proportional. We got to make sure we remember that. So let's look and see what that means. Well, when a ratio is easy to find, the numbers are super easy. So for example, look right here, 4 to 8. My proportion is 4 to 8. Well, how did I go from 4 to 8? You know it, multiply by 2. So how do I go from x to 10? I multiply x by 2. So essentially I'm going backwards, so I take 10 and divide by 2. That's an easy one to find, right? So the ratio is 4 to 8 or 1 to 2. We're saying that it's the smaller one to the larger one. So it's 1 to 2 ratio. How do you go from x to 10? Multiply it by 1/2 and you get 5. So how do you do this one? Going from 3 to 9, another easy one. Same here, right? The ratio is the same. We're going from 3 to 9 or 1 to 3. So that's my ratio. So this guy over here, you're dividing it by 3. So if we're going to set up a proportion, it's pretty simple. All we're going to do is say 3 to 9 is now 4.5. Where does 4.5 go? On top or bottom? Hope you said on top because that's where it goes. And then you're going to put x down there. So how do you go from 3 to 9? Multiply by 3. So how do you go from 4.5 to x? Ding, 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 ding. Did you say multiply by 3? That's what you do. All right, so 4.5 times 3, that gets you your answer to get that other side there. Okay, nothing really big here. Same proportions, same thing we've been working on. All right, why don't you do this one? 3 to 8. Oh, wait a minute. Can you do that one? That one's not as nice. Before we had something like 3 to 9. You multiplied it by 3. But what on earth do you multiply 3 by to get 8? It's ugly. Not so nice, is it? The ratio, if you remember from one of the other lessons we've covered in the past, what's the ratio of this guy to that guy? Well, if you said 3 to 8 or 8 to 3, that's exactly right. The ratio is just 3 to 8. So what's the ratio from x to 10? Well, what we're going to do is we're going to set up a proportion. We'll put 3 over 8. Where does 10 go? Does 10 go on top or bottom? If you said on the bottom, you were absolutely correct. Then you put the x on top. So now we can't really see how does 8 go to 10. Well, I don't know. But what I can do, what I can tell you, is 3 times 10 is 30. Now it's 30 divided by 8, and that gives me x. So then it's 30/8, or we reduce it to 15/4. We reduce it even further, and we get 3 3/4. Okay, so this is 3, and this is 3 3/4. 3 to 8, 3 3/4 to 10. All right, so if they are ugly numbers like that, No big deal. Just set up a proportion. You're good to go. All right, why don't you do these ones on your own? Is this a nice ratio? What is the ratio? First of all, I'll give you a hint. It's 5 to 7. Or 7 to 5. Just make sure you put the x in the right spot. Solve it. All right, did you get it? All right, so this is what you should be doing. 5 is to 7 as 12 is to x. All right, set up a proportion. 5 to 7 equals 12 over x. Cross multiply and divide. Cross multiply, you get 12 times 7 gives you 84, and then you're going to divide that by 5. Okay, so you should have got, what is that, 16 and 4/5. All right, so that would have been the length of the other side. Does that make sense? Well, if you think about it, 7 is to 5. This one's a little bit bigger than that guy. 16 and, what is it, 4/5, I think, is a little bit bigger than that. So we're good. Awesome. All right. Now, if we're given the ratio, can you go backwards? Look at it here. If the ratio is 3 to 7, what's x? If the big guy, imagine the big triangle here, is 7, and the little one is 3, we're comparing them, 7 to 3, well, you can solve for x, right? That's no big deal. You just take 7 to 3, and then you match the 14 up, top or bottom. You see the top, you're right on. Bottom is x. So how do you go from 7 to 14? Multiply by 2. Bam. How do you go down here? Multiply by 2, and you get x equals 6. No problem, huh? Just remember that that ratio that they give you is the first part of the fraction. It's the first part of the proportion. So you set it up here, 3 to 7, 3 to 7, you're good to go. You can also write it 3 over 7 equals x over 14 like I did down here, and all I did was move the top to the bottom and the bottom to the top. Let's keep going. All right, why don't you do this one? Ratio is 2 to 5, what's x? And just a quick note there, usually if I say the ratio is 2 to 5, that means the small guy is 2 and the big guy is 5. All right, let's do it. You got it? The top one's 5. How do you go from 5 to 15? Multiply by 3. So how do you go from 2 to x? Multiply by 3 again, and it's 6. All right, so now here's the fun part. This is where we're going to talk about the solar system. Now, I'm just going to go through these pretty quickly. Some sweet information here I've gathered. Thanks to the credits down there on the bottom right if you want to check them out. It's a sweet website. All right, so let's look at these facts real quick. Pretty cool things when we look about the sun. Here's that big old bright ball in the sky. It's 870,000 miles in diameter, and it's 27 Earth days per their sun day. So it takes 27 of our days for it to have one day in the sun. And it's a cool 5,500 degrees Celsius. No big deal. You could live there, right? Not at all. Well, Mercury, first planet closest to the sun, 40 million miles to the sun. It's 3,000 miles in diameter. 88 Earth days per their year. 27 Earth days per Mercury's day. And the temperature varies from negative 184 to a hot 465. Now, notice the difference here. 40 million miles to the sun. Let's look at Venus, that green planet. 70 million miles, almost double the distance. 7,500 miles in diameter. And their year, get this, their year is shorter than their day. Mind-blowing, isn't it? It takes 224 Earth days for it to go around the sun, and it takes 243 Earth days for the planet Venus to spin around once. That's just crazy to think about. How do you have a birthday when it's like that? I don't know. All right. And then our lovely planet, the Earth. 90 million miles to the sun, 8,000 miles in diameter. Oh, and there's what? What do you know? One Earth day in our day. There's our bowling ball of a moon. And Mars. Let's look at Mars. 140 million miles to the sun, 4,200 miles in diameter. One Earth day is about one day on Mars. About the same. Now we jump past the asteroid belt and we go to Jupiter. Jupiter is 485 million miles to the sun, 90 million miles in diameter, and 12 Earth years is 1 year. And look how fast this guy moves. 10 Earth hours is 1 day. This thing spins 10 hours for a day. Unreal. And then notice this one. Saturn, our ringed planet, 890 million miles to the sun, almost double the distance from the sun as Jupiter was. Crazy. And this is such a fast spinning planet too. Look at that, 10 Earth hours is 1 day there. And it's a chilly -175. And then we got, the most famous planet of them all, Uranus. It is 1,800,000,000 miles to the sun. Double that of Saturn. Crazy, huh? Double that. And then look at the most famous planet of them all, Neptune. 2.8 billion miles to the sun. And we can't forget little old Pluto. 3.7 billion miles to the sun. Notice when we get past the asteroid belt, all the planets are pretty much double the distance from the previous planet. Pretty cool, huh? There's a formula in there. That's math as well. So there's our solar system. And what we're going to do now is we're going to talk about making a scale model of the solar system. We're going to try and figure out how far each planet would be if we made a scale ratio. If I said, hey, let's just do this. 1 inch just happens to be 1,000,000 miles. Okay, 1 inch is 1,000,000 miles. If I'm going to make this, I'm going to make a scale system. I've got, I'm taking out some basketballs and ping pong balls and putting them on my street. And I want to measure out how far the sun is to Earth and to Pluto and all these guys. So 1 inch is 1,000,000 miles. So if the distance from Mercury to the sun is 40 million miles and our scale model is 1 inch to 1,000,000 miles, how many inches would it be for the Mercury to be from the sun? Here's our model. If I put the basketball down as the sun, I get the ping pong ball. It's 40 million miles. How far would it be? How many inches would I have to put it away? Well, if you remember from our similar figures from before, our scale is 1 inch to 1,000,000 miles. So 1 inch to 1,000,000 miles. Well, where would I put the distance from the sun to Mercury? Where would I put that 40 million? Here, here, right. So we put X on top, 40 million on bottom. Divide it out, 40 million divided by 1 million, and you get 40 inches. So if you're going to put the basketball down as the sun, and then you're going to put 40 inches away, that's where you put your ping pong ball of Mercury. It's 40 inches away. Why don't you go back, and now I want you to convert it into feet or yards. All right, it's going to be a huge undertaking for you to go through all these. So pause the video. I want you to go back, and if you didn't write down the distances, I'll be nice. Here they are. Here's the planet distances to the sun. So Mercury was 40 million, Venus was 70 million, Earth was 90. Would you convert this to feet and yards for me? Where would you need to set up these other planets if you're going to make a scale system? All right, did you get the trick? Figure the trick out yet? All you really had to do is take off 6 zeros, and that was how many inches you had. So then you convert those inches to feet and yards. Not that bad, huh? Take off 6. There you go. Here they are. So Pluto, 103 yards away. 103 yards away if 1 inch was 1,000,000 miles. Crazy. Let's think about that. Why on earth is the solar system so big and spread apart? If you use that same ratio, how big would it be if you think about this? That the sun, if it was 1.5 inches big, the Earth would be 1/10 the thickness of a piece of paper. Pretty crazy how big our solar system is, huh? Well, can you find unknown lengths of similar shapes and proportions using ratios? I bet you can. Why don't you answer that question if you haven't? Thanks for joining us as we talked about the solar system and finding unknown measures in bowling balls and planets. This is Matt with mathsmath.com. Thanks for joining us. Check us out on Facebook at Solving Maths Problems and on Twitter, Maths Math. And enjoy math.